so far we have dealt with the continuous time signals and discrete time signals, how we can convert from continuous time signal to discrete time signal. And what the thing is that, so if we have a continuous time signal, then some kind of operations we can do in that. Even in discrete time signal, some kind of operations we can do it. So what are the operations we can do? So those things we will be clearly seeing on this. So types of operations can be classified into two types. So like the operations can be done on the dependent variable as well as the independent variable. So before that, let me solve the question which I given in the last class. So here we have to convert this into, we have to find the x of n. So now we have to put the t which is equal to nts. So if we put t which is equal to nts, then this will be of e power minus 0.5 nts. So we know the fs value is 10, so means the ts value will be 0.1. So if we substitute the value of ts here, then this will be x of n, which will be equal to 1 by 2 e power minus 0.05 n. Okay, so this is how and continuous time signal can be converted into discrete time signal. Okay, so this is what the procedure to convert it. So now let's begin into the next topic, so which is quite important and will be more interesting, guys. So please make note of it. So here two type of operations that we can do it. So one is that operations on a dependent variable. So operation on dependent variable. Then another thing is that operation on independent variable. Operation on independent variable. Okay, so thing is that let us first start with the dependent variable. So what are the operations that can be done in the dependent variable? Operations, different kind of operations. Operations on. So what we mean by the operation is that some kind of activity or some kind of things that we are going to do. So first thing, which is amplitude scaling, whether diminishing or exceeding. So we are going to do amplitude scaling. So whether we are going to scale it higher or maybe scale it lower. So it will be amplitude scaling. Second thing is that amplitude reversal. So the first one is with y-axis. Now the second one is with the x-axis. Amplitude reversal. Sorry, both are with that only, but here we'll be substituting not with the scaling. Here the sign will be changed. So now the third operation, which will be the modulus. You guys know about the modulus, right? So only positive quantity. So next is add and subtraction of DC. Add or subtraction of DC. DC means constant value. So these are done on the dependent variable. So dependent variable means what? The total x of t, the entire thing. So entire signal we are going to add a thing. So first let's start with the thing. So first operations that we are going to start is the amplitude scale, amplitude scaling. Sorry. So amplitude scaling. The scaling factor may be less than 0 or greater than 0. Depending upon the factor, it will be exceeding or maybe decreasing. Okay. So given that x of t over the signal t. So x of t is the signal which is represented over the time period t. Okay. So let us plot the given signal with the amplitude scaling factor of ax of t versus t. Okay. So the process is that we have to multiply all the parameter of vertical axis by the value a. So here the process is, so x of t, we know that a signal is an physical phenomenon. So where we have to multiply all the parameter. So multiply all parameter of signals parameter of vertical axis. So here important thing is the vertical axis. So y axis only the dependent operation will be done by a. So a may be any number. So maybe less than 0 or greater than 0. That is maybe that is constant value. So here let's take an example. So I am going to draw a triangle signal. Okay. So this will be the actual signal and this will be the scaled version, amplitude scaling by the factor of a. Okay. So if we draw it, so that normal triangle, so I am taking this like this way. So let me give the values of this. So this will be over the time period t, and this is x of t. So the value which is starting from 0, positive value is 2 and negative value. So this is an even signal. I will explain that later. So the peak value which is equal to 4. So here if you see the slope, so here initially less than 0, the slope s is equal to 0. So after minus 2 to 0, the slope which will be equal to positive 2. So after that, the slope which will be equal to minus 2, and then again the slope will become 0. So okay, slope is nothing but the variation of changes. So here in order to find the slope, this will be divided by y-axis divided by x-axis value. So 4 divided by 2 will be 2. So as it is increasing, so I'm giving the value that is positive 2. So here if you see the value is decreasing, so I'm giving the value of it. The general formula is y2 minus y1 divided by x2 minus x1. So this is how the value to find out the slope. So you can apply this to find out the slope here. So one more thing, we can also find out the area of this. So what will be the area is that area will be as it is triangle, so of base into height. So 4 into 4, so this will be 8. So this will be the area of the thing. So now let us scale this one. I am writing in a blue color pen. So we are going to scale this signal with a value 2. So here we are going to change y of t which is equal to 2 times the x of t. So okay, so we are going to multiply, means what will happen is that each value will be multiplied by the 8, multiplied by 2. So if we draw it, then how this will be there is, so the same thing, but the values will be get changed. X-axis will be remain same because there we haven't done any operation. So only vertical axis only the scaling will be done. Okay, so this one will be changed to 8. So if you see here the slope which will be equal to 0, but here the slope will be positive 4. Here the slope will be minus 4. Here the slope will become 0. Okay. So if we calculate the area of this, so A2 which will be equal to of into 4 into 8. So it will become 16. If you see the scale of factor, the A which is here, A which is equal to 2, right? So the constant term is 2. So by the factor, the area will be get multiplied. So this is how the amplitude scaling process will be take place. So similarly, if it mimic this process for the amplitude reversal, so let me write the second operation, that is amplitude reversal. Amplitude reversal. Here the same, but what the thing is that we won't multiply with any factor. So if the x of t over the graph of t is given, then we have to plot minus x of t. So which is what amplitude reversal. So even you can consider the scaling factor a which is equal to minus 1 here, but we usually don't consider like this as amplitude scaling. So we'll take this process as reversal. So what the thing is that the process will be mirror image to vertical axis, sorry, horizontal axis. So because this is minus x of t, right? So every process will be taken. So take a mirror image with respect to horizontal axis. So take mirror image. So means mirror image with the horizontal means that is x-axis with respect to horizontal plane or horizontal axis. Okay, so this is what the process generally take place. So let me draw one simple diagram so that you guys can able to understand it. So any signal you guys can take it. So I'm going to take the same triangular signal here. So if we draw it like this, the same graph I'm going to take. So which is t, so which is x of t. Okay, so this is from minus 2 and this is plus 2. This value is 2. Okay, for now let's take this as 2. So let me tilt up this because it will come in a down direction, right? So if we take the mirror image of this, then what will happen is that the exact mirror image, so the value will be changed to downwards. So the y-axis, x-axis value will remain same. So this will be minus 2 and this will be 2. This value will be the reverse, so minus 2 over the t. So here the y of t which will be equal to minus x of t. So this is how the amplitude reversal process will take place. Just a mirror image over the horizontal axis. So next one is the modulus. So I will teach this in the next class. So please go over the examples that I give so that it will be very helpful to follow up on the next class. So next thing is the modulus. So I will be dealing this with next class. The same thing, x of t over the time t, we have to plot the value of modulus of x of t. So means only negative values will be taken reference over the horizontal axis. So I will explain this with the graph in next class. Okay, so this is how the modulus value will take place. After that, addition and subtraction of the DC value. That thing also we can discuss in next class. So okay guys, so next class we can discuss about these things process. Thank you.